In our last video, we saw different possibilities for the slope, calculating it with the graph, calculating it with the formula algebraically. And we saw some special cases, like in example 1c, we saw that this type of line, called a horizontal line, will have slope of 0. We saw in 1d that the vertical line, the lines that go up and down in this way, have a slope that's undefined. So these are important things to keep track of. The slope of a horizontal line is 0. The slope of every vertical line is undefined. Now, let's talk more about the equations of these lines. So the equations of these lines has that slope built into it. That's why it's important to fully understand the idea of slope. And in fact, a lot of these equations we're going to look at in this class and in your 1324 class are coming from the formula for slope, right? It's all kind of what it's built on. We'll see many types of forms of these linear equations, but the most convenient ones are the slope-intercept form. And by the name, it kind of tells you the pieces that you're going to need. We're going to say if a line has a slope that is defined, that's important, and labeled as m, so we use the letter m to signify slope instead of having to write it out every time. So if it has a slope of m and a y-intercept labeled as b, so that y-intercept is going to be where we cross the y-axis, so the point, the graph crosses the y-axis. It's called our y-intercept. Then the equation of this line is given by y equals mx plus b. And again, that m is the slope, and the 0b is the y-intercept, because if it's crossing the y-axis, it's going to have this form. So 0 is the x, and our y value is that b part that we're adding. Now, something important to note, like it says here, the y variable must be isolated on one side of the equation for it to be in slope-intercept form. Again, you'll see other versions of an equation of a line, and this one's unique in that the y is solved by itself. Let's try it. Example 2. For each of the graphs in example 1, find their respective equations. So we're going to do 1a and 1b to start. So looking back at 1a, we found a slope of 3/2 in both versions. So we're going to use 3/2 as our m. And from the graph, we can see that we're going to cross that y-axis at that 0, -2. So this is our y-intercept. So we have a slope of 3/2 and a y-intercept of 0, -2. We have m, that's our slope, is 3/2. And our y-intercept, abbreviate intercept int, is that 0, -2. So with that, we can say that our b value, following our definition, 0 and the y value is the b, we have a -2. So going with our formula, with our form, I should say, y equals mx plus b, plug in the m, plug in the b, and we have y is equal to 3/2 x minus 2. Or you can say plus -2 if you like that version better. But that's our equation. Let's try 1b. Again, we need our m, and we need our y-intercept, and eventually that's going to give us our b value. All right, let's go back to our graph, 1b. We found our slope to be -1/2, so that's our m value. And we picked this nice point already on our y-axis. Where does our graph cross? At 0, -6. So our m is -1/2, and our y-intercept is 0, -6. All right, so let's write in our values. 0, -6. Well, that means that our b value is just the -6. So going into y equals mx plus b, we'll have y equals our m value, which is the -1/2, times this x, plus a -6, or we can simply say -6. And there it is. There's the equation of our line in slope-intercept form. So you can see how that slope-intercept form is so nice when you have the slope and when you have the y-intercept. Let's do a couple more. What if we look at example 3 and we do the same thing? We want to find the equations of the lines for 1c, example 1c, and example 1d. Let's check out 1c first. So looking back at 1c, example 1, here it is, 1c. Here it is. We had a slope of 0. So our m value is 0. And what was our y-intercept? That was at 0, -1. So m is 0. M is 0. And our y-intercept was 0, -1, which meant that our b value is -1. So going into slope-intercept form, y is equal to mx plus b. I have a 0 for my m. I have y equals 0 times x plus b. Well, that's a -1. So I'll say -1. But that's a little unusual, right? When we have 0 as a coefficient, what is 0 times any number going to give us? Well, it's going to give us a 0. So it's like that part cancels away. And then what's left over then on the right-hand side is just that -1. So this b value is all the part that's left. And what was unusual or what was unique about the slope being 0? Well, that's when we have a horizontal line. So when we're dealing in a horizontal line, we don't have any more x value here. Our equations are simply going to be y equals some number, and that number happens to be our y-intercept. You can also think of this, just to kind of make sure we remember the form of it. This is basically telling us the y value is stuck at -1. If you look at the graph, all of these y values, all the ordered pairs that we could possibly pick here, are all going to have a y value of -1. Now, what about example 1d? What about this case? The vertical line case. What did we say was unique about the slope of that one? Well, on the vertical line, our slope is undefined. So this m value is undefined. And even if we could find a y-intercept, for this particular graph or any vertical line, I'll write that in here, vertical line. Even if we could find a y-intercept, if I go to start writing my equation, can I write in the word undefined times x, plus the b value? This really doesn't make sense. So in a vertical line case, I cannot write it in slope-intercept form. But that doesn't mean there's not an equation. Like the way we said the horizontal line is telling me the y value is stuck at -1, in the vertical line case, we're going to say that the x value is now stuck. If I go back to my graph, what could I say about any of these points along that vertical line? Well, my x value is always going to be -3, right, for that particular graph. So it's like the x value is stuck at that particular number there. And in fact, this is summarized right here in our special cases. If we have a horizontal line passes through any number k, then that equation is going to be y equals k. There's no x involved in a horizontal line equation of a horizontal line. If it's vertical, though, and it passes through any real number k, then its x is equal to a number. It's saying that that x value is now stuck at that particular number, whatever k may be. Now, if you're uncertain of which one is which, to avoid guessing the equation of a horizontal or vertical line, you can always make a table of x and y values and see which variable does not change numerically, right? Are the y values remaining the same, or are the x values remaining the same? And if they are, you can tell the difference between the vertical and the horizontal.